This is module 30, Inequalities in a Triangle. So one of the things that is evident is there is a certain relationship between the angles and the sides of a triangle. They are actually interconnected. So if you take the longest side of the triangle, it will always, always, always be opposite the largest angle in a triangle. Because if you think about it, think of taking like a straw or your compass that you've been using constructions with. If you open it up and imagine that the pencil and the compass, so like this side here would be the pencil, this side here would be the, and you open it up or closed it, depending on how far open or how close you have it, imagine that opening being a third side of the triangle. So this is what's called, think of it as a mouth. The wider you open the mouth, the wider the angle is, the larger the side that's opposite that angle is going to be. So the longest side and largest angle are always going to be opposite each other, and that's also true for the smallest angle and the shortest side. They will always be opposite each other as well. Okay, so we have our theorems. First theorem says if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So, for example, we have this figure here. Looking at this, you can see that AB is greater than BC because AB is 8 and BC is 5. So what does that mean? Well, the one that's opposite 8 is C. The one that's opposite BC is going to be A. So that means automatically that angle C is going to be greater than angle A. So, in the next theorem, you have if one angle of a triangle is larger than another angle, then the side opposite the larger angle is going to be longer than the side opposite the smaller angle. So this is conversely kind of the opposite. We're now dealing with angles. So if you know that an angle is larger, that means the angle, think of the angle as a mouth, the side that's opposite the angle, the larger angle, and the side opposite the smaller angle, they're going to be connected to where you can conclude that BC is greater than AB, just because the angle opposite BC is greater than the angle opposite AB. So, here's an example. It says list the sides of triangle PQR in order from shortest to longest. So, I see that we have this angle here is the smallest. So that means that has to be our smallest side. This angle here is in the middle, so that means that has to be in the middle. And this angle here is the largest, which has to mean that this side is the largest. This is the list from shortest to longest. QR, PQ, and PR. Okay, another example, list the angles from smallest to largest. So again, I've labeled the angles as such. So we know that this guy here is the largest angle, so this angle, or largest side, so the angle opposite this side is going to be the smallest angle. The middle one here, opposite the middle angle, and then of course largest side, always opposite the largest angle. So we have angle B, angle C, and then angle A, listing it from smallest to largest. Okay, another example. This is just kind of a real-world example. So you are constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is 27 feet long. The left slope is about 24 feet long, and the right slope is about 20 feet long. You are told that one of the angles is about 46, another one is about 59. What is the angle measure of the peak of the mountain? So, the best way to do this, I give you multiple choice, but we'll go through how to solve this algebraically. Draw a picture. So, draw the diagram, label the certain parts. We have the 46 is opposite the 20, the 24 is opposite the 59. For the triangle sum theorem in a previous module, you add these two together, subtract them from 180 to get the third angle. That means that the largest side is 27 feet. This is using the triangle sum theorem, so that means we get 75 degrees. So we can now label that the greatest angle is 75 degrees. Triangle inequality theorem. This is basically the theory that of how to construct a triangle. The sum of the lengths of any two sides of a triangle is going to be greater than the length of the third side always. If it's not, that means you can't construct a triangle. So anytime you take the sum of two sides, it always has to be greater than the third side. So for example, this first one here, I take AB plus BC. That always has to be greater than AC. And all of these have to hold true. If they do not hold true, that means automatically you can't create a triangle. So sum of any two sides in a triangle, you add them together, they have to be greater than the third side. All right, so here is my diagram, and I also have my three inequalities that have been set up. If you solve each one of these inequalities, that basically gives you the possibilities of what your x value can be. The first one's pretty easy. If we solve the first one, we get 24 is greater than x. So that means your value of x has to be less than 24. So x has to be less than 24, or 24 is greater than x. If you solve the second one, that's actually not possible because you get x greater than -4. And even though there are some positive numbers that are greater than -4, if we pick the value of -3, that's a negative dimension, so we can't actually use that. And last but certainly not least, if we subtract 10 on both sides, we get x is greater than 4. So we need to satisfy these two inequalities. So if I were to write one single inequality, I would get 24 greater than x, which has to be greater than 4. So my value has to be between 24 and 4. So anytime you set up the three inequalities, you're going to immediately throw one of them out because they will evaluate to a negative number. So this one you throw out. So here's another one. We have a triangle has a length of 11 inches and another of 15 inches. So again, draw your figure. So we have 11, 15, and x. Set up your three inequalities. Okay, and the one that you're going to throw out is this one, because when you subtract 15 from both sides, you get a negative. So you can immediately throw him out. This one here evaluates to 26 being greater than x. And this one here evaluates to x being greater than 4. So we're going to take these two inequalities to create a single inequality, which gives us 26 greater than x, which is greater than 4. So that's what our two constraints are. It has to be between 26 and 4, but not including 26 and 4. Okay. So we have Hinge theorem, and again, this is kind of one of those things I was alluding to in the previous part of this module. But if you take your compass and that we've been doing all constructions with, and just kind of imagine that you open it up to 88 degrees, and then you imagine that you close it to 35 degrees. What do you think is going to happen to that third side? Well, what happens is as you decrease the angle measurement, the side opposite that angle measurement is going to decrease. So what Hinge's theorem states that if two sides of one triangle are congruent to two sides of another triangle, again, think of your compass, your pencil, and your needle, and the included angle of the first is larger than the included angle of the second, so the angle that is created with your compass and your needle, your pencil and your needle of your compass, then the third side of the first is longer than the third side of the second. Just think of the opening, how far the opening is in the triangle basically constitutes how long the other side is. And the converse of this is also true. So if we know that two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So again, we're looking at this angle here because we know the two sides are congruent that are opposite. So this angle here is going to be different because this side is larger. That means the angle has to be opening to a larger size in order to create that side. Same deal here, so we have to close the compass, the pencil, and the needle to get DE to be 9. So we close it up. So we say that the measure of angle C has to be greater than the measure of angle F by the converse of the Hinge theorem. So how is this applicable? Here we go. So, given that we have ST is congruent to PR, how does angle PST compare to angle SPR? Well, first thing that I notice that I can do, and this is from a previous module, we can label that this side here is congruent. So I'm looking at an angle here, and I'm looking at an angle here. Well, the opposite this angle, since we know that we have two congruent sides to these triangles, the opposite angle here is 23 degrees, or 23 inches, and opposite this angle here is going to be 24 inches. So how do the angles compare? Well, we can state that you're given that ST is congruent to PR, and you know that PS is congruent to PS by the reflexive property. So that's in a previous module. Since we know that 24 inches is greater than 23 inches, or PT is greater than RS, so two of the sides of SP, or STP, are going to be congruent to two of the sides of triangle PRS, and the third side in triangle STP is longer. So, by the converse of the Hinge theorem, you know that the two angles, and measure of angle PST, is going to be greater than the measure of angle SPR. This, I think, is a little on the complicated side, but just think the opening of the angle is going to determine what the length of the opposite side is. So the angle's measurement will be directly related to the opposite side's measurement. Okay, what about this example? So we have, again, a reflexive property that we can label. So we know, that's your answer. We're looking at the measure of angle P, QPR. So QPR is this angle here, and we know it's larger than measure of angle QPS. All I'm going to do is I'm going to say that this is like 33 degrees, and since it's larger, that means that the other one is going to be, I don't know, 30 degrees. I'm just using numerical examples. So that means the side opposite the 30 has to be smaller than the side opposite the 33 degrees. So which one is the larger one? It has to be RQ, or QR, because it's opposite the larger angle. Okay, so what if I ask the flip way of that question? So if PR is equal to PS, also again by the reflexive property, we know that this segment is congruent to this segment. So RQ, they tell us, is less than SQ. So I'm going to just pick a value. RQ, let's say this is 8. We know it's less than SQ, so let's say SQ is 9. So opposite this angle, opposite this side, this is this angle. Opposite this side is this angle. So which angle, RPQ or SPQ, is going to be greater? So the answer is SPQ. Why is it SPQ? Because it's opposite the larger side.